Hey developers, welcome back. We're thrilled to have you join us again. It's day 29 of our dev challenge, and today we're diving into stacks. This is an essential concept in computer science and software development. You've probably heard this term thrown around, but what exactly is a stack and why should you care? Understanding stacks can significantly improve your problem-solving skills. Let's break it down. We'll explore the theory and then jump into some practical coding. First things first, a stack is a linear data structure. It's one of the simplest and most commonly used data structures. Think of it like a stack of plates. You can only add or remove plates from the top. This makes it very intuitive to understand. This property of stacks is what we call LIFO, last in, first out. This means the last item you put in is the first one to come out. The last item you put in is the first one to come out. Simple, right? This principle is used in various applications, from undo mechanisms in text editors to function call management in programming languages. Now let's get our hands dirty and implement a stack using a list in Python. This will give you a practical understanding of how stacks work. Open up your favorite code editor and let's get started. Make sure you have Python installed on your machine. First, we'll create a class called stack. This will encapsulate all the stack operations. Inside this class, we'll initialize an empty list. This list will act as our stack. This list will hold our stack elements. It's a simple yet effective way to manage our data. Python class stack. Next, we'll define a method to add elements to the stack. This is known as the push operation. We'll call this method push. It takes an element as a parameter and appends it to our list. It takes an element as a parameter and appends it to our list. This is how we add items to our stack. Python def push self element. Removing elements follows the LIFO principle. This is known as the pop operation. We'll create a method called pop to remove and return the last item in the list. This is crucial for maintaining the LIFO order. But first, let's handle the case where the stack is empty. We need to ensure we don't try to pop from an empty stack. Python def pop self. We should also have a method to check if the stack is empty. This is a simple yet important check. This is a simple check to see if our list is empty. It helps us avoid errors when performing pop operations. Python def is empty self. Finally, let's add a method to peek at the top element without removing it. This is useful for checking the top item without modifying the stack. This is useful when you need to see what's on top of the stack. It's a handy feature for many algorithms. Python def peek self. Now let's put it all together and test our stack implementation. This will help us ensure everything works as expected. Python my_stack equals sign stack hash. Pushing elements my stack push 1 my stack push 2 my stack push 3 print my stack dot pop hash output 3 print my stack dot pop hash output 2 print my stack dot pop hash output 1 print my stack dot pop hash output. Stack is empty, and there you have it. You've successfully implemented a stack in Python. You've just implemented a stack using a list in Python. This is a great step forward in your coding journey. This foundational concept is crucial for many algorithms and systems. Understanding it will give you a solid base for more complex topics. Keep practicing, and you'll get better each day. Consistency is key in mastering these concepts. If you found this video helpful, don't forget to like, subscribe, and hit that bell icon for more developer challenges. Your support helps us create more content. See you tomorrow for day 30. Happy coding. Keep pushing your limits and exploring new concepts.